So I've got a few things that I wanted to do here while we wait. I wanted to just kind of show off a little bit, and we're going to have some fun because we're still, as we said, we're still waiting on a few people. And so sometimes with these demos, people may be a few minutes late, and so we want to give everyone a chance. There's another one. Welcome to everyone coming in. I'm going to move my camera down here, and we're going to get started. I want to kind of show you guys some interesting things. Oh, I'm sorry. Did you say something?
I did.
Well, here, I'm going to move my camera down here, and I want to start showing you guys some stuff. So, as I said, we're still waiting on a few people. So I'm going to try and hold off on my big speech, but I wanted to show you guys just a little bit about, well, I guess what some of the stuff that we might be getting into in this course. I have a little circuit here that I wanted to throw together here just for fun while we wait for everybody else. What I've got here in front of me is called a breadboard. And so, if you guys have any experience with electronics, this might be something that you're familiar with. A breadboard is essentially just something that I can build circuits here on really, really easily. And now you guys don't have to worry too much about what I'm doing here. I just wanted to show you how we can take a few components here and just shove them into a breadboard, and we can make something kind of fun. And again, just while we're waiting for everybody else. There's a lot of different components when you're working with electronics. And, we're going to learn about each of them throughout the course, at least the basics of it all. It all kind of comes down to a basic understanding of the flow of electricity. And so that's also something we're going to talk a lot about. And so, this kind of gets into the real two sides of the course here. If you choose to take the Arduino course, there's going to be the programming side of things, which, if you guys have done Python code or Java or anything like that, it's pretty similar. And really, a lot of the code that we'll do in this course is fairly simple. And, so I think a lot of the learning will be, at least in the beginning, will be having to do with the basics of electricity. And, obviously, it's something you want to have some respect for. In our course here, we won't be working with any dangerous amounts of electricity. In fact, we'll be working with amounts of electricity that are thousands of times less than what you might find in an outlet in your house. So far from being able to even be able to give you a slight shock, but still very, very useful. And there's a lot of interesting things we can do here. And so I'm just going to throw together this circuit here real quick. Just a few components. See if I can't get it right on the first try. Well, I just about got this done, and then I'll get to show you guys what this does. Something that's really fun for me about electronics is, and you guys might be able to relate to this, is it just simply, it allows you to really interact with your world. One reason that I really love the Arduinos and love what we're going to be learning all about in this course is because it really connects the programming side of things and the hardware side of things, the real tangible side of technology. Like I said, you guys don't have to worry too much about what I'm doing here. I more just wanted to show you while we waited. It seems like we've got a good group coming in. Don't usually have demo classes this large. It was pretty exciting to get to talk to this many people about this. Like I said, it's a big passion of mine. And I'll show you too something fun. This is something I just recently started learning a lot more about. And it gets into the concept of audio amplifiers and what all you can do with those. And it's pretty fun stuff. So I'm just going to show you here. I believe that solves it. Now we just got to add power. And then I can add a speaker. And then I can show you guys what this actually does. When electricity was first invented, you guys, one of the main things that people were utilizing it for was communication. And so, you know, you guys might have heard about Morse code and other things like that, but they eventually figured out that even audio signals really were just electronic signals, just kind of scrambled up. And if we could figure out how to decode them, then we would be able to one-to-one be able to convert audio into an electronic signal and then back into audio. And so that's just a simple example of what's going on here. Maybe my battery's dead. Well, this is why I always keep my notes around, you guys, in case I ever forget anything. I always have it handy with me, just what might go wrong. I'm going to pull this up here real quick, and I'm going to show you guys. Then we're going to move forwards. I don't want to spend too much time here. And there we go. So you guys can see that in a couple minutes there, I was actually able to build myself an amplifier here for my electric guitar. So I was a little concerned I wasn't able to get it working. I just had 2 wires worked around there. And so I wanted to show you guys this again because it gives you a simple example of, even though we're not actually using an Arduino here, but this is just why it is that I love knowing about electricity, you guys. Even if you don't want to be an engineer, or you don't want to be a programmer or anything else, having an understanding of electricity and electronic components can be so much fun. Whether you're interested in music, or you like art, or science, or anything. I mean, there's just so many things. Electricity is such a versatile thing. It's used in so many areas all around our world. To have even a simple understanding of it can allow you to do some pretty fun things. So anyways, I just wanted to show you guys that one for fun. But anyways, with that, I hope everybody enjoyed the demo there. We're going to move forward. And so really, what we want to get at now is I want to talk to you guys about, again, what exactly is this whole Arduino thing? I know I just showed you here, obviously we're working with electricity, and, you know, but where does this whole Arduino thing come into play? And so that's what I want to talk to you guys about next. So I'm going to move this all out of the way now. So Arduinos. I'll hold this one up here. I'll show you guys a picture of this too, so you can actually see it. This is an Arduino, you guys. You can see it's about the size of my hand. This is the slightly larger version. There's also, this is called an Arduino Uno, and then there's the Arduino Nano, you can see is even smaller. And then there's one that's about half the size of that. That's called the Arduino Pro Mini. And so you can imagine these things just get smaller and smaller. But essentially, you know, it's a long shot to say that this is a computer. Oops. You can see they're pretty sturdy. You know, you could throw them around, don't have to worry too much. But this thing is essentially, in ways, it is like a computer. An Arduino is a small chip that I can plug in. You can even see it has a USB port on here. And so I can plug this directly into my computer, and I can open up some software, and I can upload programs to it. And now that's obviously sounds pretty cool, but then it comes to the question, okay, so, you know, once you have a program onto this thing, then, you know, where does it go from there? How does that really help you with anything? And so that really is what the course is all about, you guys. Because once you have a basic understanding, and I do mean basic, you know, it doesn't take a lot to know, or to you know, get to play around with these Arduinos and get them to do some pretty interesting things. The way that they're designed is so that you know, they can be used by professionals, and they can be used by beginners. They can do some really advanced things, but they can also you know, make really complicated things a lot easier. And so it's great for learning. And especially then if you have an interest in really knowing how a computer works, or how you know, more complicated electronics work, obviously this is a great start. So that's what an Arduino looks like. But again, what exactly is it? And it falls under the category of a microcontroller. So I'm going to open up my presentation now, and we're going to take a look at some stuff here. So, as we said, this is the Arduino course. And that's, you know, one of these things. So the Arduino course entails a whole lot. We obviously are going to talk about Arduinos. We're going to talk about the basics of programming an Arduino, what exactly an Arduino is. And as we said, we're going to talk all about the basics of electricity and electronic components. So it's a fairly broad range of topics. Essentially, best way to describe what exactly an Arduino is. Arduinos are microcontrollers, or really Arduino specifically is a company that designs microcontrollers. And they don't just design microcontrollers, but they design, programs or software that can be used to program them. And so then once again, we get into the question, okay, so what is a microcontroller? And simply put, a microcontroller is, as we see here, it's a small chip that can be placed inside of a machine or electronic device and essentially act as a brain. It could also go into a robot. These could be used for more complicated devices, but that's essentially what it is. It is a brain. You see that we've got all these different little pins here, and these are actually individual holes, and I can just easily plug a wire into here and then connect it right over to my breadboard. That's what's cool about the Arduino Uno. It's got all those pins on it so that you're really easily able to connect up to different electronic devices, and then you can write a program to control those various devices. And as we said, then it's as easy as just plugging this thing into a USB port and plugging it into your computer and hitting a couple buttons, and you can upload a program to it. And as we said, I mean, these can be used as brains of machines and electronic devices. From anything as complicated as a calculator, all the way to an autonomous robot, or even a flying robot at that. Let's make it even crazier. People do it all. So Arduinos are really, really cool, you guys, because again, it's endless. You can spend your entire life coming up with different projects and different ideas, different things that you could build with an Arduino. But it's only the surface of it. It really is. Arduinos are an introduction to the world of microcontrollers. There's all kinds of different ones out there, and they all have their advantages and disadvantages. There's easy enough to make your own kind of version of something like this even. Arduino is an open source company, and so what that means is that they're pretty cool with sharing everything that they make. They obviously sell the genuine Arduinos. This one you can see actually says Arduino on it. It's kind of tough to see, but it does say Arduino on it. And so this particular one is a genuine Arduino, but you can see this one doesn't actually say Arduino, and that's again because the software and all of the work for the Arduino project, it's all open for anyone to use. And so there's all kinds of companies that make these things and sell them. And so you can buy these things for as cheap as a few dollars online, at least these Arduino Nanos. And as we said, then they could still be used with the same Arduino software to program. And there's all kinds of different microcontrollers, as we talked about, some more complicated than others. The bottom line, though, if you wanted to know really what the difference between a microcontroller and an actual computer is that generally a computer can do like multiple. A computer would be like multiple of these put together, and so they could have you'd have one program or one brain of a computer that's handling memory, and another that's handling running various tasks, and then oftentimes, especially nowadays, you have multiple processors or multiple cores in computers, so they're able to run all kinds of different programs, whereas this one can only run one program at a time. And so that really is the big difference between Arduinos and computers. They're just They're not as powerful, but there's still a whole lot that you can do with them, and they're a lot easier to use, and obviously a lot smaller. So I wanted to show you guys just a few examples of some stuff that we can do here. Obviously, I've got my own, I've got a few of my own, but then I wanted to show you some more advanced examples. I wanted to show you ones that, this one is actually one I wanted to show you that is just very impressive. This gets into the whole world of microcontrollers, and it gets into, you know, again, it gets into some of the more complicated side of things, and then really what it takes. And so I just wanted to show you guys this one because it's very impressive. This is a scientist who's worked on this, and he's worked on others like this, but made some very, very impressive works. And so this is actually a robot that he's programmed, again, utilizing microcontrollers similar to the Arduino. But in this video, he actually talks about this, and he had to design his own microcontroller for this robot that had the speed of processing required to, you know, to allow this robot to pedal its legs and ride its bike around. But that one is obviously very impressive, very, very technical feat. That guy is a very well-known, very accomplished scientist. This is a guy on YouTube. This is just a really fun video, and this is a car that he made. And obviously, it wouldn't be very impressive, but this car can actually drive on walls and on the ceiling of his apartment, and it's all 3D printed. And so he goes through the process. And this one, he did actually just use an Arduino, and well, and he ended up using some other, he made some fancy electronics, and he had to get everything as light as possible in order to make this work. But, you know, just another example. And then he also, I wanted to show you too, he utilized a actual, he made his own app for this. And so that's just another thing I wanted to show you guys, or just to introduce you to the idea of, is that it's something that people do a lot with Arduino actually, is you can hook your Arduinos right up to your phone with Bluetooth. And so people make all kinds of devices that then they can make an app on their phone that they're able to control, and with Bluetooth. And so I just wanted to see if I could get to that part where he's showing his actual app. But I have to look through the video. But you guys can see, once again, just another small example of what can be done with Arduino. Here's another one. This one's pretty interesting. Quadrupedal robots are fun. There's a whole lot of designs for things like this. You know, this one's kind of like a crab or something. There's also like, you know, 8 and 6 legs ones, or people make ones that look more like dogs or cats. And it's always very interesting. You know, I'm working on one of these myself. But obviously you can see, you know, that's, there's a lot to something like this. But the bottom line is that they got a couple motors, and then you can see right up top, they have an Arduino. And really, you know, as complicated as something like this might look, the Arduino takes away all that complicated functionality of it, and really just packs it into one package, and it just makes the whole process, you know, they're coming out with all kinds of toys. There's companies designing kits for thousands of dollars that utilize really, really cheap components in a kit like this, and it all really comes down to them just writing a good program to go along with it. And it's you know, it's pretty cool. So anyways, I just wanted to show you guys that too as well, just to give you an idea, a very, very small idea about what is possible with Arduinos. The possibilities really are endless. Obviously, I like robots, so I'm showing you guys robots, but People make machines also. People make machines for drawing. People make their own 3D printers. You know, people make you know, like laser etchers. People make I saw a guy make an automatic door lock. That was an interesting one. So he actually had like a card that he could swipe, and then it would unlock his door for him. And once again, just, you know, so a few things he was able to buy off the internet and throw together using Arduino. So I wanted to just show you guys a little bit about what all will be in this course and the next one, because there are in fact 2 levels of the Arduino course here. The first level really goes through the basics of electronics and just working with electricity, and we talk about some basic components. We obviously break out in Arduino and we do some programming, and we get to take our breadboards and we build a few circuits. And so I definitely think that will be the first step. And then you know, once we kind of go through that, once we have our base, once we have a really good understanding of how the Arduinos work and how we can use them to create different things, then we'll move forwards. We'll do some kind of final project at the end of the first course, and that will involve, you know, the use of a few different electronic components and obviously some programming. And then it'll also give you guys the opportunity to kind of take a look at you know, some things that you'll have in your kit and some of the things that we learned, and then, you know, maybe even try and come up with your own project. We'll see. The second level of the course, we're going to then really get into some more advanced electronic components. Some of the things we're going to talk about are motors and this concept called PWM, and that's a pretty interesting one, and that's a lot of fun to learn about. So you guys have to stick around for that in level 2. But then the next unit that we'll get into, or the units, will be sensors and the advanced sensors unit. And so in units like that, we're going to talk about things like light sensors and ultrasonic sensors, which are also another kind of distance sensor, essentially. And so, you know, you can, I can even show you one right here. This is an ultrasonic sensor. You guys may have seen some of these around, and essentially what this is, it kind of looks like Wally's face, but one side is essentially a speaker, and then the other side is acting like a microphone, but they're sending out ultrasonic signals. And so one side sends out a signal, and when that sound wave bounces off a nearby object, the time which it takes for that sound wave to then return to the other microphone, we can then use that to determine how far away a nearby object actually is with relative accuracy. And so then we're able to measure, you know, down to the centimeter, how far away something is from us. And that's a very, very useful thing to be able to do in any regard, but especially if you're building some kind of machine or some kind of robot. Very important. And so there's also other kinds of, those are called proximity sensors, and there's other kinds of proximity sensors. Sensors like, as we said, you know, there's different kinds of light sensors, or there's what are called infrared sensors. And then there's also laser sensors, and that's how a lot of the self-driving cars that you guys are, you know, probably hearing more and more about nowadays, that's how a lot of those function. Although they also use cameras to keep track of things. They use a conjunction of both. They'll have ultrasonic sensors around the sides to detect if anything's getting close. They'll have a laser radar system. So they have basically a laser that's spinning 360 degrees around, and it's, you know, checking everywhere all around it the distance of nearby objects, and so it can essentially draw its its world around it. And yeah, you guys might also know that that's how those Roombas work, those automatic vacuum machines you see running around people's houses now. And so there's all kinds of interesting things like this, you guys, that you know, we're seeing more and more and more in our world as we become more automated, more electronic. And it becomes increasingly more important for us people living in this electronic world, to not forget how it works, and to make sure that, you know, we understand what's really going on, and how all of it really functions. And then it can also really help us in our lives too, in order to, if we have that deeper understanding. Another thing we'll also talk about is piezoelectricity, and this is a cool one. You know, there's a lot going on. People are utilizing piezoelectricity to create different kinds of generators, or for various types of microphones is what it's often been used for in the past, but they're also used for all kinds of things. Essentially, I'll grab one. I've actually got one right here, though it's kind of damaged. This is a piezoelectric disc, you guys. You can see it's like a little copper disc with a white plate on it, and that white plate is like a quartz kind of material. There's different kinds of materials that we found all around the world that, excuse me, that we find that when we hit the material, you know, I don't know if I'd be able to give you a good analysis here, but essentially, piezoelectric materials are a material that, when they receive vibration, they create sound, or I mean, they create electricity, or vice versa. When they receive electricity, they create sound. And so we can use these. When you guys accidentally pull a buzzer off of something in the store, that's one of these things going off inside of it. Something really, really small. It can run on a very tiny battery, and they can just go on for hours and hours. And so they're very annoying, but they work really well. And so in that way, you can use them to actually create different tones. You can control the sound that's coming out of it. You can make your own synthesizers or other things, or there's all different kinds of things that people do with them. And so we'll have a whole lesson on that, and then different things that we can do with those, and we'll show how we can create different frequencies, and even use them to play a little song. And then again, at the end of course 2, we will have time for a final project. At the end of the course, we'll have a good understanding of how to use different motors and sensors and programming the Arduinos, and a good understanding of the basic principles of electricity. And at that point, you guys will be ready to start looking into some more complicated things. I'll tell you right now that, you know, the reason that I started doing this originally, the reason that I got into Arduinos, is because I've always had an interest in engineering and robotics. And I spent some time doing research on how it is that I can get involved in robotics, and how it is that I can really start a career in it. And the truth is, you guys, is that, I mean, robotics especially, but programming, electricity, you know, the engineering fields even still are so new, and there's so much innovation going on constantly, that the only way to really get involved is to just get involved. There's no, you know, there is no course that can tell you exactly how to do it. There's only just you and your passion for it, and that's all. And so Arduino, again, is a great place to get started in really understanding your world. And if you have an interest in getting involved in engineering and getting involved in the incredibly new field of robotics, then Arduino is definitely your starting point. But you know, there's a lot more to learn from there, you guys. Like we said, the possibilities with Arduino are pretty much endless, and it is only your imagination that can create any real limits. And of course, your skill level too. Not to say this is all easy, but I will say that utilizing the Arduino and utilizing the free software that they've got, you'd be surprised at the things that you can put together in a short period of time. So I want to go over some of what we're going to use actually in the course in order to do, you know, do a lot of our wiring and our programming and everything. And so obviously you guys can imagine that right off the bat, you can see, you know, I've got my breadboard out here and I've got my Arduino. The truth is, you guys, is that, you know, it's easy to make mistakes on these things. And so, you know, you want to be careful, even though, as we talked about, there's not any dangerous amounts of energy we're working with, but the danger exists for our chips here, for our actual electronic components. And, you know, they can fry pretty easily if we give them too much power or if we ask too much of them. And so we have to be careful. We have to know what they're capable of and make sure we're not asking too much. And so, you know, there are a number of different ways we go about that, and we'll also talk about that in the course. But one really great way for us to get around a whole lot of issues that come with troubleshooting circuits here, and I'm going to just bring it up here. It's called Tinkercad. Kind of an interesting name, but I will say that I have learned to really appreciate this software. It's really cool. Once again, totally free software. You guys can come online and check it out. I'm going to stop my video here for a moment. So, you know, you can see here, I just came to tinkercad.com, and so I can log in here. If you guys have a Google account, you can just log in with Google. You know, you can see over here, they've got a few different sections, 3D design, circuits, and other things. We're going to go to circuits, and this allows us to just go ahead and start designing whatever we like. I can create a new circuit here, and what this will bring up is a page that is basically just a blank sketch, a blank workbench for me to work on. And then on the right side here, I have all kinds of basic components. So you can see we've got an Arduino in there. We have a, you know, we have a DC motor. We've got a servo. We've got LEDs and batteries. And so we've got, you know, most of everything that we would need to start designing some circuits. And so this is what we're going to use in the course in order to save ourselves a lot of trouble. Obviously, we do want to get to, we want to get to really building the circuits and seeing how they really work. But we want to make sure that we're prepared for that before we do it. You know, any engineer always takes the time to make sure that he's got the correct wiring or the correct math done before you try and plug it in. It saves you a lot of hassle. And so, you know, we can see how this software not only allows us to actually place components. See, I can place an LED here. And if you guys don't fully know what an LED is, an LED is basically a little light bulb. And I'll actually turn my camera back on here so I can show you. So obviously, I think most of you know of the term LED, but you know, maybe you guys aren't used to actually looking at a single LED and what it looks like and how it works. LED stands for a light emitting diode. And a diode is an electronic device that only lets electricity flow through one way, in one direction. So you can see that this LED has one pin that's actually longer than the other one. The long one is where we put the power on, and then that's where the power comes out. And so the power flows through the LED, through the long pin and out the short pin. And the energy flowing through it creates light. And so obviously, you guys can imagine we use these things pretty often. That's essentially how light bulbs work. And yes, they are very, very, very useful. And it really is, I think that was probably one of the earliest inventions. No, not the first electronic device, was one of the first, was the light bulb. So LEDs are pretty cool because they're really efficient. We just have to be careful not to fry it. But as we said here, we're able to simulate an LED, and we can even change the color of it here. You can see I can change it to white or green or red or orange, whatever I like. I guess I'm holding a blue LED, so I'm going to change this LED here to blue. And once again, you can see on our actual sketch here that we have, I can blow this LED up too. We can see that we have one long pin and one short pin. And so, as we said before, the long pin is where we send in power. The short pin is where it all flows out from. And so, if we wanted to then connect our LED to power and turn it on, all we'd have to do, and I can rotate this here, all we have to do is connect the LED to the battery. Now, I want to take a second to talk about this because, as we said before, LEDs, we were saying how electricity flows through the one way, but I want to make sure that everybody understands that electricity flows in a wire, or that's kind of a loose way of going about describing it, but essentially that's how it works, is that electricity flows through a wire kind of like water flows through a pipe. And so you can imagine when the pipe is smaller, you can get less water through. And if you try and force water through the pipe, then you're going to get resistance, you're going to create heat, and you're going to create pressure. Obviously, if you have a much larger pipe, then there's a lot less resistance, there's a lot less pressure and heat, and things flow more evenly. And so, it's the same thing. When we have a lot of power that we're trying to move, we use really big wires. When we have small amounts of power, we use really small wires. It's pretty logical. So, you guys probably hear all about voltage all the time. You hear high voltage. You may have heard, the voltage of your house. Generally you guys have either, well, in America, it goes off of a 120 volt system. And then in other countries, they might use different systems. They might use 220 volts. But, essentially, then we have that other one, voltage, which just refers to the actual, the speed at which the electricity is flowing through the wire. That's essentially, how we can break it down to the most simple aspect of it. And so, once again, we have to think about the flow of electricity. Where it's different than water is that electricity always wants to flow in a full circle. Essentially, it wants to go from its source. It wants to go from positive to negative in the quickest path possible. And we can see that, I'll just do this. Electricity always wants to take the quickest path back to, we call this ground. we have positive and negative. We call the positive power or voltage, or we call it various things. But essentially we have power and we have ground. And so power is obviously where the power comes from, and then it wants to flow back to the original source. It wants to always flow back to the beginning. Kind of like water always wants to flow downhill, electricity always wants to flow back to the source, and it will always take the quickest path to get back to the source. And so that's important, because that means that if you connect a battery directly, positive and negative, like we do here, this would start to get really hot, because then all the energy from the battery would be flowing through this wire in a continuous loop and creating what's called a short circuit. Because you can see, well, that's basically what it is. It is a very short circuit. We have the circuit is going from directly from point A to point B. It's as short as it can possibly get. And when that happens, the battery will start to get really, really hot really fast. And so that's something we'll talk about more and more. If you guys choose to take the course, we'll learn more about short circuits and how exactly that works and the flow of electricity. But essentially, what it all means is that in order to power this LED, now that we understand that electricity flows through the wires and that the LED is only going to allow power to flow through it in one direction, well, then we know that we just have to take the positive and connect it to the long side of the LED, and we connect the negative to the short side of the LED. And then we can start the simulation up, and we can see that that does, in fact, power up our LED. So now, I don't know, for some people that might be totally new. For me, I guess I've always grown up around electricity and learning this stuff. So for me, it just is kind of second nature. But I do think that it definitely is something that it takes some time to really develop a greater understanding of. Essentially, though, you guys, we see that we have power flowing, and power flows from positive to negative. And that is really your basics of electricity right there. You have power and ground. And if you were to even open up your a receptacle in your home, that's all you would see. You would see, essentially, I mean, you might see 3 wires, but technically what you see is 2 wires. You see a positive and a negative. And that's the basics of how electricity works. Is we have the actual power that flows from the battery, and these are charged electrons. These are electrons that actually hold that hold electrical power, and they move it to the LED, and then those electrons are then used up by the LED, and then those uncharged electrons then move back to the battery. So that's where, we can kind of imagine how, if we allowed the power to go directly from the source back to negative, and it never used up the charge in those electrons, that's what then creates the short circuit and the heat, is the direct feedback to the battery. So that's why it is that we have to do it like this. We have to make sure that the power and the ground never directly touch. That's the most crucial thing in working with electricity. You never want to let power and ground directly touch. It'll cause sparks. It'll cause all kinds of things. So I also wanted to show you guys too, we're talking about electricity as being a circuit. And the definition of the word circuit, what it is, a complete circle or a complete cycle is essentially what a circuit is. And so that's why you can see when we connect the LED to positive and negative, we have a complete circuit. Oops. I don't know what happened there. Anyways, when we have the LED connected, we have a complete circuit. And so this obviously would then lead to our LED always being on. And so this is what a switch is, you guys. This is all a switch is, really. You see a light switch in your house. This is all that it's doing. It takes, either the, generally they'll take the power, but in this case, we're going to take the ground. You can do either one. And then we have a switch. And so you can see, and this is a good indication, when the switch is actually on, that turns the LED on. And you can imagine it literally is, it's like us touching the two ends of a wire together. That's basically what a switch is doing. When the switch is open, it's open. And then when we close the switch, we're touching the two pieces of metal together. And now we allow the circuit to be completed, and then we have energy. And you can see we can turn the switch off, and that turns the light off. And so that's how a light switch works. And then you can also imagine you could use something like this over here, and this is a knob, and we'd even be able to use this to kind of control the actual voltage and control the amount of power that we're feeding our LED. And this would be one way that we could then control the actual brightness of it. I'm going to go back to black wires here. Color coding is also important. I should say that. I always, it's a good practice. It's a very standard practice to use green for your ground or for your negative wire, and to use black or red for your positive wires. That's just a good practice. And so then we can see here, there's the LED, and then I can kind of adjust it slightly. It's obviously very sensitive in this simulation, but you can kind of get the idea. We're able to have a switch and a knob, and we can control the brightness. We can actually control the circuit all around. Or something else we could do, we could also add a button, and then I can just show you how that's essentially, a button is the same thing as a switch. The difference is that with the button, it doesn't stay on. And so if we start the simulation now, we can see when I click the button, the LED comes on. When I let go of the button, then the LED goes off. And so, this is really the basics of circuit design, you guys. And you can see how this software is really, really useful. I was able to figure out some really useful circuits the other night that I had been really playing around with for a while and been struggling to get, just trying to work it on my breadboard, because you end up causing problems, or you end up accidentally, frying a component or something other. But doing it like this really allows you to see how everything works, save yourselves some time and also money for components. And it allows you to then find the working example and then go and build it. And so that's just, that's why I really like this software. And that's why we'll be using this software for a good part of the course. Again, the idea is that we'll come in, we'll talk about a concept, we'll talk about an idea, we'll build the circuit here. And then once we get the circuit built here, then we'll pull out our breadboards and our Arduinos, and we'll build it for real. And so I guess, that really is the last part. I can just show you guys here real quick. I actually have all the stuff to do this. And so I have a battery right here, and I have an LED, and I have a potentiometer. And so, you can see that I'm connecting the long side of my LED. I'm going to what I'm going to do is I'm going to connect the long side of my LED directly to the power, and then the potentiometer here. A potentiometer is a knob, and it's changing the potential of the circuit, because you can imagine that when the circuit is partially closed, then it has a lower potential. When it's totally open, it's maximum potential, or when it's totally closed, it's minimum potential. Or, I mean, totally open. But anyways, so then I am able to use the potentiometer to then control the brightness of my LED. And I've got a resistor here just so that I don't burn out my LED too. And there we go. So you can see that now, and I can now use the knob to actually control the brightness of my LED. And you can see that's pretty simple. And so that really is the basics of electronics, you guys. And then the next step, would be to show how we can then hook up a circuit like this to our Arduino. And then we don't have to actually have the knob controlled here. We can control it automatically utilizing a program. And so this is the kind of stuff we're going to be doing all through the course. We're going to be taking a look at the principles of electricity. We're going to be taking a look at real world things, like we said, robots, machines, and self-driving cars. And, we're going to talk about how these things really work at the most basic level, and break it down, and then try and build a simple example of it ourselves. So it's going to be a fun course, you guys. Again, there's 2 levels of it, and I really encourage you guys to check it out. If you have any interest in engineering, in robotics, in electricity, in programming, all of the above, I would really recommend you taking this course. Like I said, the reason that I get involved in this was because I wanted to be an engineer, or I wanted to be not just an engineer, but I wanted to explore the new fields of science, the fields of science that are still in development, and nobody can really tell you exactly how to do that. But what the people who know best are saying is that working with microcontrollers and just learning to actually build machines and robots and other things, that's the only real way to get into it. Is to just start doing it. So I encourage you guys to get started in your own pursuits and to start learning a little bit of Arduino. That will be all, though, for today. If you guys have any questions for me at this point, feel free to throw it out there. Otherwise, again, I really hope that you guys liked the lesson, and I hope to see you all in the future. But otherwise, you guys are all welcome to go. I think that's going to be it for today. Does anybody have any questions about the course at this point?
So about the course, is there any equipment we need to physically buy or get?
Yes, absolutely. So I have actually put together a list of components. There's actually a kit here. I'll pull it up here. So great question here. I'm glad you brought it up. The materials for the class come out to about $50, so it's nothing major, and this includes everything that you need for both levels of the course and then some. You guys will have extra components for continuing your own projects. We definitely tried to keep it as slim as possible for this, so I didn't want to, we're not asking you guys for anything major. This is all stuff that you will definitely need to really get started in your pursuit of Arduino and everything. The kit here will come with an Arduino board, it'll come with a breadboard. It'll come with a lot of the components that you've seen here, and then other ones that we'll be working with in the class. It'll come with a few different sensors, a few different types of motors, a few different drivers, a lot of really good stuff. And so, yes, that will be something you guys will need for the class. But as we said, the class is also going to be, we're going to do a lot of circuit design online. And then the first few classes will mainly just be done online as we're going to be learning about the basics of electricity and electronic components. And then we're going to learn about Tinkercad. And then once we start to really get comfortable there, then we'll start doing the actual circuit design with our breadboards. But yes, so you guys will need to purchase one of these kits at some point, about 3 or 4 classes in, and that will then but again, that'll take you through for the rest of both the courses, and then should give you a lot to work with for future projects as well.
Yeah, and my last question, is there like a programming language that Arduino uses?
Yes, and so that was one thing that we hadn't really talked a whole lot about. Essentially, the Arduino language, or the Arduino software, utilizes C++. It utilizes kind of its own software, its own library, but it essentially is C++. And so I said in the beginning, if you guys have any experience with Python or writing Java, then transferring over to something like C++ will actually be pretty simple. And I can even show you a little bit about, or just kind of what this looks like. You can do coding from within Tinkercad, but we'll also be using this. This is the official Arduino IDE. And so this is what you can use to actually upload directly to your boards. And so this is where I was saying, I can plug in my Arduino, and then I can come up here and I can hit upload, and I can, throw it in there. I don't have an Arduino plugged in, so it gives me a problem. But essentially, programming with Arduino is pretty straightforward. I can create a new sketch, or just a new blank sketch. And it's very easy to use overall. And as I said before, if you guys have any experience with with Python or with Java, it'll be a breeze. And a lot of the programming that we do in the course, especially in the first part of the course, we're going to be focusing heavily on the understanding of the electronics, and then we're also going to talk about the differences between C++ and then other object-oriented languages, and we're going to talk about how we can actually use C++ to do some useful programs beyond just coding the Arduinos. Just actually using C++ syntax. So yes, we will get into all of that, but you guys don't have to feel too concerned about that. As we said, I think the programming will be very gradually introduced along with the all of our information about the electronics. But yes, that's I'm glad you brought that up. C++ is the language that we'll be using here, and that is an incredibly powerful, incredibly popular language. So especially, once again, I mean, if you guys have any interest in engineering or robotics, or even if you just have any interest in programming, I mean, to know C++ is pretty important. So there's a lot of good things you'll be learning from this class. And so yes, good questions there. I'm glad you brought that up, Steve.